yesterday are still a part of this. So the note sheet you took on a separate sheet of paper, or we just did a paper, one of two things you can do. One of them is you can just straight staple it to it, and that's fine. Or if you want to copy them back over, that's fine too. Because I do not take a grade for note sheets or taking notes. Because at this point, I think y'all realize taking notes helps. Helps y'all learn, helps you understand. If it does, do it. If not, it's up to you. H of x. So the first one we're looking at, or picking up where we left off yesterday, we want to write a function h of x whose graph is a reflection in the y-axis of the graph of f. Now I'm going to rewrite it. Are you sure? Yep. I'm just rewriting it here. You do not need to rewrite it because it's easily seeable on your paper. It's just right there. We have it. I'm going to rewrite it so we're not having to scroll. I'm not having to scroll up and down, back and forth to see the function again and again. If you want to write it, that's fine. So we want to write a function h whose graph is a reflection in the y-axis. So if we look at the general form for reflection across the y-axis, it's f of negative x. And the f part of the general form is just saying we're talking about this function f. We're talking about the function f. If we're applying to g of x, it would just be g of negative x. It's just telling us how we're naming it or which one we're applying it to. Just like with horizontal translation, we do not have f of x anymore. We've replaced the x in f of x with negative x, which means every x in the function needs to be replaced with negative x. So we still have the absolute value bar, but instead of x, we have negative x. Plus 3 plus 1. Everything else stays the same. We're just replacing every x with negative x. And then we're going to simplify. Now, because there is no number or sign in front of our parentheses here with the negative x, we'll just drop it, and it will give us the absolute value of negative x plus 3 plus 1. There are no like terms because we can't take the positive 3 out of the absolute values, and we can't put the plus 1, the positive 1, into it. This is as simplified as it gets. So that's it. H of x is equal to the absolute value of negative x plus 3 plus 1. We'll look at 2 more reflections and go from there. So we want to write a function h whose graph is a reflection in the x-axis of the graph of f. Now our reflection across the x-axis is our negative f of x, negative f of x. Found it? There we go. So we have negative f of x, because that's our reflection across the x-axis. So we still have the negative, and we can replace f of x with what it's equal to, which is our absolute value of x minus 5 minus 4. Questions on how we got here? Now at this point here, we can distribute this negative through. Now when we multiply something by the absolute value, an absolute value expression, we leave that whatever we're multiplying it by out front. So when we multiply the absolute value of x minus 5 by that negative 1, it's just going to be negative absolute value of x minus 5. But we also have to apply that negative to the negative 4. It will still be 4, but a negative and negative make a positive. Telling us that our reflection across the x-axis would be negative absolute value of x minus 5 plus 4. Questions on this here? Are you ready for the next one? Write a function g whose graph is a reflection of the y-axis of the graph of x. To reflect across the y-axis, we use the general form f of negative x. And really the f part is just saying we're applying it to the function f of x. Now we don't have f of x anymore, we have f of negative x, which means every x in f of x has to switch to negative x. Everything else is going to stay the same. Now we need to simplify, and since there's nothing in front of the parentheses besides the absolute value bar with our negative x, it's just going to be negative x. Telling us that we have the absolute value of negative x minus 5 minus 4. And that's it. So if we were to graph it, this is our normal function. Now the one we just did was a reflection across the y-axis. So it means all the points to the right of the y-axis are going to go to the left. All the points to the left are going to go to the right. And we said that that was going to be negative x minus 5 minus 4. We can see it is a mirror image across that line. Now our reflection across the x-axis, negative x minus 5 plus 4. We can do see that it is a flip across that axis. But that's it. Questions over reflecting across the x-axis or the y-axis? Do we feel comfortable with both of these here? Yes? No? Okay. Because if we feel comfortable with it, we'll move on. Because I do like to put more examples than are needed, and if we are all feeling good or comfortable with it, we'll move on to the next piece. First one I'm going to want to look at is vertical stretch and shrink. Vertical stretch and shrink, the general form for stretching or shrinking the function vertically is a times f of x. A times f of x. Where a is the amount that we stretch or shrink it by. Doesn't matter if it's a stretch, does not matter if it's a shrink. We're going to use a times f of x. Horizontal stretch or shrink. You want to mark out the f of ax. We're going to call it f of bx, where b is equal to 1 over a, 1 over the amount that they give us. We have this flip. The graph of y equals a times f of or f of ax, is a horizontal stretch or shrink by a factor of 1 over a of the graph of y equals f of x, where a is greater than 0 and different than 1. So we have this flip because it's saying it's a times x, f of a times x, but a, our actual value is 1 over a. So if a is 3, it's telling us that it's stretching or shrinking it by, a is 3, so 1 over 3, 1/3. We have a horizontal shrink of 1/3. We have this flip that has to occur. So instead of naming both of them a, 1a is what we have in it, we flip it and plug a back in. Let's give it two distinct variables, two distinct things that we're referencing. So we're not trying to talk about the same thing with the same letter. So multiplying the inputs of a before evaluating the function stretches the graph horizontally, where a is between 0 and 1, and it shrinks it when a is greater than 1. Again, double letters kind of mix things up, opposite of what we think. But before we delve too far into horizontal stretch or shrink, let's look at vertical. Let f of x equal the absolute value of x minus 3 minus 5. And we want to write a function h whose graph is a vertical stretch of the graph of f by a factor of 2. Now our vertical stretch or shrink is a times f of x, where a is the amount that we stretch or shrink the function by. Now for this one here, they told us a is what? So we'll replace a with 2. And we can also replace f of x with its function, absolute value of x minus 3 minus 5. Questions on how we got here? Last thing we need to do is simplify. We need to distribute that 2. 2 times our absolute value of x minus 3 would be 2 times the absolute value of x minus 3. 2 times our negative 5 would be negative 10. That's it. Questions on this here? Let f of x still be the same function. We want to write a function g whose graph is a horizontal shrink of the graph of f by a factor of 1/3. Horizontal stretch or shrink is given to us by the general equation, f of bx, where b is equal to 1 over a. What did they tell us our value of a is? Value of a is 1/3, yes? So really what our value of b is 1 over 1/3. We can't leave a fraction in a fraction. Well, 1 over 1/3 is 3. Really what we're doing is just taking whatever that value is and flipping it. So 1/3 would become 3. If we had 3, it would become 1/3. We just take the fraction or the number and flip it. If you're not sure how it flips, we can just do 1 over whatever that value is. So that helps us because it tells us that the value of b is 3. And that's what we actually plug into the function. That's also part of the reason why I have you write it down as f of b, or we're going to use f of b, or f of bx, instead of just f of a where a is equal, we have 1 over a. Too many of the same letter being used. Questions on this here? So we have f of 3x, yes? Which means every x in the function has to be replaced with 3x. Still have the absolute value bar, but instead of x, we have 3x minus 3 minus 5. Well, pretty much we do need to drop the parentheses, telling us that we have 3x minus 3 minus 5. Questions on this here? Would you all agree in saying that the tricky part with this here is just remembering to flip? That's the only thing with it. Let's look at 2 more of these. Write a function g whose graph is a horizontal stretch of the graph of f by a factor of 5. So we have this where b is equal to 1 over a. So this would be 1 over 5. And just like the previous one, we have f of 1 over 5x. We're going to replace the x in the equation with 1 over 5x. Questions on any of this here? And these are a little weird. It's a little strange how this works. The fact that to stretch it horizontally, we need it to be fractional. Or in fact, to shrink it horizontally, we need it to be a bigger number. But it's kind of how it works. Let's look at one more horizontal or vertical stretch by a factor of 0.25. So for this one here, we're going to use a times f of x. So we'll replace our a value with the amount that we're shrinking it by, which is our 0.25. And then we're going to replace f of x with the function, our absolute value of x minus 1 plus 2. Then the next thing we need to do is to distribute this across both of these here. Now our 0.25 times our absolute value is just going to be 0.25 times the absolute value of x minus 1. So we just put it in front. Now we need to multiply our 0.25 by 2, which would be if we have 2 quarters. Yeah, 0.50, 0.5. If we're not sure, 0.25 times 2, 0.5, 0.50. That's it. Questions on vertical stretch and shrink, horizontal stretch and shrink? We feel good with these here. In that case, we'll look at the last thing. Last thing we're doing is combining these transformations. Now, some, especially depending on the book and how it's written, and how the, not so much how the book's written, but how the questions are written, we could say that this is a linear equation. Don't write this. And because A is our vertical stretch and shrink, so we have 0.25, we have no movement left or right, and we're going up 3, so plus 3. We can write it this way, simplify, so we have 0.25x plus 3, and that's our final equation. And as long as the transformations are put in a certain order in a certain way, this works fine. But if they're not, it's going to give us something completely different. So the way I approach all of these is we take it one transformation at a time. So the first transformation they tell us is a vertical shrink by a factor of 0.25. Now, what we call this really doesn't make a difference. We can call it h of x, g of x, l of x, m of x. Doesn't matter. We're just going to call it g of x for now, or h of x for now. And because it's a vertical shrink by a factor of 0.25, our vertical stretch or shrink in the general form is a times f of x, where a is the amount that we're stretching or shrinking the function by. Since it's a shrink by 0.25, it tells me that the value of a is 0.25. We can also replace f of x with what it's equal to, which is just x. So we have 0.25 times x, which would be 0.25x. So that takes care of the first function. Next piece, 3 units up. So we can call this next part g of x. We want to use a different name so we're not naming it based off the same piece. Also, the general form for our vertical translation up and down we said was f of x plus k, yes? We use the f of x part to say that we are applying it to the function f of x, yes? What are we actually applying it to this time? This one here, yes? So instead of saying f of x, we would say h of x plus k. Because f of x is just a name, right? Because in the general forms, we're saying we're applying all of this to f of x. We don't have to. We can apply it to any function. So we're just saying we're taking that function h of x, the 0.25x, and moving it up or down a certain amount, whatever the value of k is. And our value of k in this case is 3, yes? And it would be positive or negative? Positive because we're going up. What's our g, or h of x? Yeah. So it feels like there should be something more to it with the g of x part, but it's really saying, hey, we're taking the function we just stretched vertically by 0.25 and applying this new transformation to it. That's it. Anything in front of the 0.25. So it's just 0.25x plus 3. At this point, you're saying, well, we could have just stuck them in there, we would be fine, yes? And yes, because the way they set it up, we did a vertical stretch and shrink first, then up 3, we get this here. You do not need to write this. I wouldn't write this. I'm going to go in reverse order. I'm going to do the up and down, our vertical translation up 3 first. So it's still positive 3. F of x, our absolute value, it's just going to be our x. Replace f of x with x, k with 3, telling me that I have x plus 3. Then we're going to apply our vertical shrink of 0.25 to our h of x. So a is 0.25. H of x is our x plus 3. Then like we've been doing, we'll distribute it. And we do get 0.25 times x gives us the 0.25x. Well, that's the same, yes, to what we got on the first one. But what else do we have to do? We also have to multiply the 0.25 by the 3. We don't get plus 3 anymore. We have plus 0.75. You can all see how switching those two change the order. Because our vertical stretch and shrink is affecting the y values. Our translation up or down is affecting the values of y for each point. So if I do the vertical up and down first and then apply the stretch or shrink, it's going to change the number if we do it the other way. So especially a lot of the vertical translation reflections, if you do them first and then the up and down, it doesn't have a big impact. But if you do it the other direction, it will. All right, let's look at one more. Last problem. Let the graph of G be a translation 6 units down, followed by a reflection in the x-axis of this here. So the first function, or first transformation they listed is f of x plus k, where k is the amount we move the function up or down. And here, the amount we're moving is 6. Would it be positive 6 or negative 6? Which direction are we moving, up or down? Down, so it would be negative. Up is positive, down is negative. When we plug in h, right is positive, left is negative when we plug it in. F of x is absolute value of x. Don't need the or parentheses around our absolute value, so we can drop them. Plus negative 6 is just going to be minus 6. Other transformation we're going to do is a reflection across the x-axis. In the general form, it's negative f of x. But since we're not applying it to the function f, we're applying it to the function h. We're just going to say negative h of x. However you label it, as long as you understand which one we're applying it to, especially as you're working it through, that's going to be the most important thing over using correct lettering here. Because here we're saying that we're applying that negative to our absolute value of x minus 6. We're not applying it directly to our negative, to just the absolute value of x. So the negative for right here, so where the negative is coming from is from our second transformation? Okay, yeah, no, that's a good question. Because there is always a chance I just accidentally put another negative where there shouldn't be. So since the second part was to reflect it across the x-axis, we're doing negative of our function. Does that answer that question? Any other questions? Now we need to simplify. We're going to distribute the negative through. Our negative times our absolute value is just going to be negative absolute value of x. However, our 6, the negative and negative, is going to make a plus. Telling us that g of x is equal to negative absolute value of x plus 6. And again, this one, just like the previous one where order matters, here, flipping it would have still given us negative absolute value of x, but instead of plus 6, it's going to be minus 6. It would give us a different value there. Questions over anything we've done? That is it. We are done with 1.3. 3 through 6, 11 through 14, 17 through 20, 27, 29, all of them are apply the given transformation. 27 and 29 are going to have 2. So there will be 2 transformations you'll do with those there. And 17 through 20, and I think one of the 2 that has 2 is going to have a horizontal stretch or shrink. So be careful with it. Just making sure we flip that. But that is it.